Hi everyone, today I'll be talking about the identity for the sum and difference of two cubes. In particular, I'll be deriving for the sum of two cubes, a³ plus b³ equals to a plus b times a square minus ab plus b square. Right? I'll be skipping the difference of two cubes because the steps are pretty much similar. Alright, so let's begin. Okay, so first of all, let's focus on a³ plus b³. Now in here, I'm not going to put fx equals to that. I think there's no x and it's just going to complicate things. So the idea is I'm going to try to test out a divisor of a plus b to see whether that works by factor theorem. Alright, so if I substitute a equals to negative b back into a³ plus b³, I'm going to see whether the remainder is actually equals to 0, and if that's the case, if it's equals to 0, then by factor theorem, alright, it's this a plus b is a factor of a³ plus b³. Alright, so I have a plus b equals to 0 and a equals to negative b. So next I'm going to substitute a equals to negative b back into a³ plus b³. Right, and what that gives me is basically negative b, I substitute into a. Alright, so you have negative b whole thing cubed, and then you also have plus b cubed. Okay, and what that leaves me is negative of b cubed plus b cubed, which means it equals to 0, and this implies, alright, this implies a plus b is a factor of a³ plus b³, and this is by factor theorem. Okay, so first of all, we already got a plus b as one of the factor, but we still got the rest of it. Right, so to push out the other factor, what I'm going to do is actually to use long division. So first I'm going to set up the long division. Right, and in here I have a³, and then I also have the other end b³. Now why am I putting such a big gap in between? Because there is actually some in between terms, plus 0 of, and now there is a and b involved, so therefore I'm going to drop the power of a by 1, so a square, and then increasing the power of b by 1, I have b, right, and then plus 0 times of a b square, and then finally plus b³. Okay, and my divisor here is a plus b. Alright, so first step, I'm going to try to remove the leading term of a³. Alright, and that's what I want to remove. So in order to do that, I will need to multiply the a with a square. So I'm going to put the a square in the quotient. Alright, and then next, a square times b is going to give me a²b. Okay, so here I'm going to be left with 0 a²b minus a²b, so that's going to give me a negative a²b. Alright, and I'm going to bring this down, plus 0ab square. Okay, next, so in order for me to remove this negative a²b, I will need to minus away a negative a²b. So in my quotient, I'm going to put in minus ab. So what this does is this negative ab times a is going to give me negative a²b, and that's all good. And this negative ab times b is going to give me negative ab square. Okay, and I close the bracket, and then of course the leading term will be gone, and then I have 0ab square minus negative ab square, so I'm going to be left with ab square. Alright, and then bring this down, I will have plus b³, and now the leading term is ab square, So aiming for that, I'm going to multiply the a with b squared. So I need to plus b squared in the quotient, right? And b squared times a, of course, is ab squared, and then b squared times b is going to give me b cubed. Okay, and that leaves us with a remainder of 0 as desired. Alright, so let's take stock of what happens. And we have a cubed plus b cubed in our original dividend, and then we have the divisor of a plus b times of the quotient a squared minus ab plus b squared, and this is the identity that I initially started to derive. Alright, so of course you can try it for a cubed minus b cubed, and it's pretty much similar steps. So until the next video, I hope you understand how this comes about and give it a try. Alright, and have fun with maths.